Yeah, okay, cool.
It's like coding with two keyboards.
Yeah, I'll be impressed if you name right. All right, now I'm going to hand it over to Stewart for his talk. I'll give him a round of applause, please.
Cool, yeah. My name's Stewart. I'm a senior iOS engineer here at Biloo. And when I'm not writing apps as part of my day job, I'm writing other apps as part of my weekend. So about 2-3 years ago, I started writing an app, and I realized like I wanted a back end for it. And so I originally started I looked at everything. I looked at Firebase, I looked at Azure, and then AWS, and I kind of wanted to learn AWS. So I was like, I'll invest some time in that. Wanted to write it using serverless, and so I went into it with JavaScript, and it was about the same time as WW20, where they released or announced Swift Lambdas. So I was like, this seems interesting. It's on the same thing I'm trying to do. So I decided to spend a little bit of time and investigate how it works and see if it would be something that would work for me. So first of all, what is Lambda? Well, there was a couple of good talks from CocoaHeads in March around backend, and one of them being, and it goes over some of the stuff around Lambdas and serverless. So if you've not seen that, go and check that out. But for anyone who doesn't know what Lambda is, it will go over a traditional sort of server backend setup. So this might be something you might see if you're working in AWS and you want to build a backend. This is with a dedicated server. So you would probably use something like EC2 to run a dedicated server that you pay for, whether people are using it or not. It would just sit there running all the time. It might connect to RDS or a database at the back end. You might have an API gateway or something like that connecting through the front so that you can transfer data through and get it back. Serverless is a little bit different. It's similar. It basically replaces that EC2 instance with a serverless Lambda. So the Lambda it's still a server, but it's basically you pay for it on demand rather than paying for it constantly. You only pay for what you use. And so when a request comes in, AWS will spin up your Lambda. It will execute the code. It will then die back down again if it needs to. If you get more instances coming in, more requests coming in, and it needs to scale, it will do that automatically for you. It will create new instances of your Lambda and absorb that extra overhead. And again, when it starts to die back down again, it'll scale back. And eventually, if you've got no requests coming, it'll kill it altogether, and it'll sit there until the next time a request comes in, when the whole process will start over again. That's basically a short overview of how Lambda works. So of course, there's a lot more into it, and EC2 does have the same sort of behaviors of scaling. You just got to manage it, and yeah, basically the minimum cost will be the cost of running the server for the duration of time that you're running it for. Whereas Lambda, if you're writing something that not many people are going to use initially, it might be a good starting point. It's not going to cost you too much, and then you might want to transition to something more substantial later on down the line if Lambda's not working for you. That's a quick sort of overview of Lambda. So why would you want to use Swift? Well, there's a lot of reasons. Basically, the same reasons we use Swift when we're writing iOS apps. It's got first-class support from Apple. It's fast. It's efficient. It's got low memory overhead. It's deterministic. So when you run it, you know that every single time you run it, it's going to give you the same output with the same input. We have great support with third-party packages through SPM. But the most important one for me, and for a lot of you in this room as well, is we already know Swift. So there's not needing to learn a new language there. If you've already worked with Swift before, it's the same, mostly the same as working on an app or anything else you would write in Swift. And there is good support for Swift server. Not so much in the Lambda space, but there is a lot of crossover. So if something works with Swift server, it will usually transition to Lambda not too badly. And in fact, a lot of something I'll show you later on is actually written. I'm using a third-party dependency through Vapor, which is a Swift server package that runs, well, basically you can run a server entirely using Swift. They built a package for Postgres, and I used it with Lambda. So there is crossover there. There is some limitations of it. So let's get into that. So I say, what's the trade-offs? There's a couple. So speed and support. Now, speed, not too bad. It's not probably as quick as some other languages, just because of that cold startup time with Lambda. When a request comes in and it's not currently running, it needs to spin it up. That could take a few milliseconds, and milliseconds in backend time can lead to quite a lot of delay when you start scaling. And obviously a cost as well associated with that if you're spending a lot of time just spinning up. Like an empty Swift package would be around about 30 megabytes. So it's not huge, but that it can at scale start to impact you. Other languages might be smaller, but by the time you add 150,000 node packages, you're probably about the same anyway. So yeah, and then support as well. The support is there, but it's not as widespread as it is for something like Node.js, for instance. There's a lot of, if you're using NPM, you've got tons of packages that you could choose from, a lot of them specifically focused on backend. Support for Swift is mostly in sort of open source area where some developers are like the Vapor packages are sort of just built by people, myself, anybody in this room that's interested in it, and provided for everybody. So the support is getting there, but it's not obviously at the same scale as it is for other languages quite at the moment. Yeah, I'm going to move on to a quick demo. And as everybody knows, live demos usually go about as well as this dog. But we're going to give it a go and see how we get on. So first things first, I'm going to show you my quick setup here. So I've got a Postgres database running in Docker at the moment, just for local debugging, and you can see I'm connected here. I've got a table with posts and a table of users, and we're going to write an API using Lambda that will connect to this and allow us to add users and add posts and read from the database. So first of all, I'll go over to my Lambda here. So the first thing to note with using Swift Lambda is it's just a Swift package. There's nothing special about it. You create a Swift package, you add your dependencies, the main one being the Swift Lambda, the Swift AWS Lambda runtime, that has everything that needs to package it up for it to be executable by on AWS. The other one I have here is Postgres. You'll notice this Neo part at the end. This all runs on something called Swift Neo. This basically being a very bare bones version of Swift. So it basically has foundation and pretty much that's it. So no URL session, no UI image, nothing of that sort. So you're kind of limited in what you can do. And it also means that when you're building something using Xcode, it will use the Swift libraries that are on your Mac, which means that if it runs on your Mac, it might not run on AWS when you actually upload it, or when you try and compile it effectively, it'll throw errors. So it's just something to note that you don't have the full support that you would normally get when you're writing an app, but the support is still good, but you will run into the odd thing here and there that doesn't work. So yeah, that's basically the package setup. The first thing that you'll notice is we have a main. It's a little bit different to just a regular main, but effectively this is dictated by the AWS Lambda runtime. The main bit being this lambda.run down here. So what this does is you provide it with your handler, which has to conform to a protocol, in this case, async lambda event handler or lambda handler. It has a couple of definitions, one being an init and the other one being a handle. When AWS spins it up, it will start this code up and then it will call handle. Anything that you return from here will get returned back to the whatever requested it effectively. In this case, we're actually going to be running with an API gateway proxy response and request. So it's not a regular sort of request that you would see, but AWS API gateway will take the request that it gets, package it up into a proxy, which is just a different form of request, and send it to us. And then we take all the information out of it we need, process it, and then return back using this response type here. And so you can basically return any sort of response you want and any sort of body you want on that, as well as headers and anything else. So what I'll do is I'll quickly run this just to show that it works. So if I go over to Proxyman here, and I've got an empty request. This is the AWS Lambda proxy request, so it's a bit large, but really all you're interested in is the resource at the top, which currently is just empty, and the HTTP method that the user is requesting. And then down the bottom, you'll have any body or parameters or anything like that that are being passed into it as well. So if I hit send on that, you'll see that at the bottom, we're getting status code 200 and AML. So our Lambda is running and it's returning data. So now we're going to make it actually do something more interesting. So I've already got a few things in here, one being models. So we have a post model, a user model, and a couple of request models here as well. We also have an extension just for enabling decoding and encoding of strings mainly. And then we have a bunch of empty classes which we're going to fill out. So the first one is this Postgres interface. So we'll fill this one out. So effectively what this is just a wrapper for the Postgres dependency that we have. It has a couple of useful methods like checking if we're connected to the database, a method to actually connect. Probably don't want to just leave data like this in your Lambda. You might want to get that from like a store somewhere, but for the purpose of this, it's fine for testing locally. It connects to the database using the information we passed in, hits connect on our third-party dependency, and then stores the connection for later. Again, we have a method here to close the connection, and then a method down the bottom just to wrap up any queries that we're going to send to Postgres. The next thing we're going to do is we're going to write a couple of services. So the first one being a user service. So this is going to use our Postgres interface that we just wrote. It has a few helper methods for creating a user, getting a user, and then converting the response from the Postgres response to something that the rest of the Lambda can then use, basically to the model type that we're going to return back to the API when somebody invokes their method. So this is effectively just wrapping up simplifying the requests to our Postgres database. So you can see all the queries here. The next one is our post service. So similar deal, takes our Postgres interface. We've got a few methods for create, get posts for a specific user. And then again, a couple of methods just to convert the responses back. Now that we've got our services set up, we're going to create handlers. And so the handler in this scenario is basically taking that AWS API gateway request and decoding it into something we can use, and then passing that request on to our services to handle getting the information from the database. So it'll make a little bit more sense when I write it here. So you can see here that we're in this situation, our user handler takes the services that we just created, and then it's handling things like create user. So we'll get an event from API gateway, in this case, the request type here. And we're doing things like decoding the body as a create user request. And then if that succeeds, we then continue on to create the user. If it fails, we're returning a response in this situation of a bad request. Obviously, the request body we got didn't match what we expected, and so we're just going to return a bad request. You could return a body here explaining the exact reason why it was bad. But in this situation, we're just returning the status code. Again, here we've got one for getting a user and then for getting the posts for a user. And you can see in this situation, we're pulling out the user ID from the path. So what in the request, it might be like user / the ID of the user. We're getting that ID out of the path of the request. And then equally, we're going to do one for posts, post handler. And again, similar deal, just basically the same as our user one, just decoding that response and sending that onto the service to process. So now we've got our handler set up. We need a way of telling our Lambda handler, the main handler, where these exist and how to interact with them. So in my implementation, that comes in the form of a router. So here we already have a struct for a route. So that takes the resource, the method that we're looking for, and then the handler, which is a method signature here, which matches the methods that we have inside our handlers. So what we'll do is inside the routers, we'll just fill this in. So inside our router, we have an array of routes. And then we also are initializing with the two handlers that we just created. And then we call a method internally called register routes. So in here, take that down, make read it a little bit easier. So we're basically just appending routes to the array. In this situation, we've got users. We're looking for method post, and if we get a request with the route with the resource of users and the method of post, then we're going to call this handler at the end, which just takes us to the method that we defined inside our handler. We also have a method in here called handle, which takes the event, filters through the events that we have registered, the routes that we have registered. If it finds one, then it will call into that handler with the event, pass the event through to the handler. If it doesn't, we'll just call back a 404 not found. And yeah, that's the crux of it, really. And then finally, we need to link this back into here. So this bit's fairly simple. We initialize our handler. So we in our initializer for a handler, we're initializing our Postgres interface. We're then initializing the services using that interface, and we're initializing the handlers using the services that we just created. And then finally, we're initializing the router with the two handlers. And then when the handle method gets invoked, we connect to our Postgres interface. We then tell the router to handle the event and wait on the response. We then, once we've got the response, we then close the connection to our Postgres interface, and then we return the response. If anything fails in there, we just fall out with an internal server error. And that's pretty much it. So if I run this now and go back to our Postman interface, if I just hit that same empty request, you'll see we're getting a 404. So our router is working. It's telling us that that route doesn't exist, just for an empty resource at the top up here. So how about if we do something that actually will do something? So let's create a user. So we've got a post on users. At the bottom, you can see we're passing in a body with the name of test user. If I hit send, you can see that it's succeeded. It's created a user, and it's given us the ID of that user. So I'm just going to copy that. So we can now go over to our get users, and you can see here that in the resource, we actually have a placeholder for user underscore ID, and that's what we were using inside our handler to get the ID of the user when we're getting a user. And down here in path parameters, you can see that we have a user ID, and then if we set the ID of the user we just created, hit send, you'll see we get the same response. So we're able to get a user with an ID. And then how about if we create a post? So we can go in here. I recommend you don't just have an API that you can just put a user ID in and then create a post for a given user. But in this situation, we'll just do that. So you go, we've created our post. It's got an ID. It's got the ID of the user that created the post, and then the text of the post itself. If I then copy over the ID of the post that we just created, we can check that our get post method works. So scroll down to the bottom, the post ID, let's paste that in there. You can see that that one works. And then finally, if I just take the ID of the user that we created again, go back here into get posts for a specific user, paste in that ID, and you can see that we get that post as well. And now if we go back to create a post for the same user, let's give it a little bit different text there. Go back to our get user posts, hit send, and you can see we're now getting both of them back. Yeah, and that's pretty much how you would go about writing that. Go back to my presentation, and then yeah, finally, any questions? Yes, Balash.
So, putting all the routes into one Lambda, is there a scalability place where you would start to split them out to different Lambdas, or?
I'm not sure about scalability, because AWS should handle it as far as if there's more requests, it should just pump up the number of Lambdas you've got. But from a manageability spec, like you might want to start splitting them out into individual Lambdas for each API. Really, you can do it however you want. There's no limit to the way I've done it. You could do it any way you want. One of the benefits of using Swift and Swift Package Manager is you could have, say for instance, you could have the Postgres interface and your services wrapped in a package, and then you can create a bunch of Lambdas handlers that all depend on those services. And equally, you could do the same with models. If you want to return models, you could actually share it between your app and the API, and so you'll never have a problem with your models not matching. So yeah, but I don't think there's a problem with scaling that specific implementation, more so than just handling the amount of requests, like handling the amount of different resources that you might get. Yeah.
I don't know if maybe you said at the start, but have you done many maybe medium large projects with Swift on the server?
Not Swift server, but Swift Lambda. Yeah, I've got a personal project that currently runs on Swift Lambda. Does have some JavaScript Lambdas as well, but the main API is running on Swift Lambda.
And just on top of that, are there any Node.js packages that you wish you had sometimes?
Yes.
What
Yeah.
kind of ones?
Mainly anything to integrate with AWS systems directly. So AWS is working on a Swift SDK. I tried using it. It wasn't quite working right. It was still I think it's still in alpha or beta. So there was still issues with it. I think it would work okay if you were on a server. If you're running in Lambda, it was having an issue with threading because you're really only limited to one thread on Lambda. So it was getting itself in a lock. So it's still early days. I think it's coming, but things like that. So if you ever want to sign an AWS request, you have to write it all yourself or find a package somewhere that does it, because you don't have support just from the AWS JavaScript library that you would if you're writing in JavaScript. So yeah, there are definitely drawbacks from that point of view.
There is a pretty good third-party AWS SDK.
Okay, yeah.
Because I ran into the same
Yeah.
problem. And actually, if you interact with DynamoDB or anything, the third-party one does a far better job of supporting Codable, which makes pulling stuff in and out of DynamoDB really nice.
Yeah.
Really nicer than TypeScript.
Yeah, I think that's one of the benefits I found with using Swift is like the codability aspects of it, and knowing that everything you get, you get what you're asking for. You're not going to get an int coming through in a string. It's always going to be a string. And if it was to try and invoke it with something it didn't expect, it would just fall out immediately. It just wouldn't handle it. Whereas JavaScript, obviously, you need to constantly check, is this? TypeScript gets around that a little bit, but you can still just navigate TypeScript in a way that basically has no types if you want to. So yeah, I think that's the real benefit I found with it, and having it compiled. It just, as soon as you've compiled it, it works. You run all your tests on it, everything works. You're not really going to run into many issues, as long as your code's solid. So, yeah.
How do you handle versions, changes in specifications, API things? Include in the paths?
Yeah, like you could either include it in the path or header. Usually probably path's probably the easiest. Yeah.
Just add extra routes to the different versions.
Yeah, you could have like a different router for each version. Yeah, but I think probably the way you would handle it on any server, you could do it the same. Yeah, I've not personally had to version any APIs, so I wouldn't know how to do it personally myself. So it's something I might run into at some point, but yeah, I think I don't see any issue with it. Yeah.
A question regarding deployment, because the demo you did was fully local, wasn't it? So when you deploy onto AWS, onto Lambda, do you have something similar to SAM where you can create all the API gateway, all the resources, and do you do it from Xcode directly, or opposite?
It wouldn't be from Xcode. So deployment is fun. It's all done through Docker. Yeah. So when it comes to building it, you have to run it you have to compile it through Docker. So one of the good things is if you go into the AWS Swift Lambda runtime repository, they have a bunch of examples for how to handle deployment. They have scripts that will do it for you. You just have to fill in a bunch of values. And so the most basic way is you just run their script. It would then compile it out into a Docker container. It will then build that out into a zip file that you can then just upload to S3, and it also has the code in there to move that across to your Lambda function. But you can also use something like, so you could use serverless. They have an example in there of using serverless as well. Something I recently just did with an API. I converted it. Previously, because when I started doing this, they didn't have a serverless example, so I didn't know how to do it. So I recently wanted to look at doing it in serverless, and that's when I found they had updated their documentation to allow for that. It's a little bit different to just running serverless deploy as you would with JavaScript. You have to first still run the script to compile, and once you've got that zip, then you would set that as the artifact and hit serverless deploy, and it will do everything else the same as it would for JavaScript. So it's a little bit more finicky, but you wouldn't do it directly through Xcode. You still need a command line to handle the actual deployment. Yeah.
What are you building?
I have an app on the Mac App Store called Dash. It's basically a glorified browser. It just keeps like all your tabs and stuff in one place so you can easily find it. And that's all written with Swift Lambda. And I'm working on a project at the moment around passing identity between people. So that is also using some Swift Lambda and some other JavaScript Lambdas. But yeah, that was when I started looking at serverless just for ease, because I did the JavaScript stuff in serverless and I was like, this is easy. Just one command and it does everything for you.
So you need Swift, JavaScript, and Swift.
I have some Lambdas in JavaScript, yeah, and some in Swift, and some I have a JavaScript Lambda that talks to Swift Lambda. And so yeah, there's no issue with having, obviously they're just sending JavaScript back and forward. Yeah.
Is it free?
Swift Lambda, yeah, or just AWS in general. Sorry.
The official runtime library.
Sorry.
And this Swift runtime library is the official.
Yeah.
Table.
Yeah. It's through the Swift consortium, so it's Swift server. So the same people that build Swift effectively at the back. So it's all Apple backed and official. There is another one. I can't remember what it's called. But there is another library that was actually out previous to the Swift one that basically does the same thing, but it's third party, so there's no first party support in there.
I'm ask a random question.
Yeah.
What do you usually use for maintaining AWS infrastructure?
Myself, I don't really do. Yeah, originally yes, but now I try and do everything through serverless, serverless framework.
Have you tried Terraform?
Not yet. No. Yeah. No worries.
Any more questions? No, another round of applause for Stewart.
Thank you. Cool. Well, that brings us to sort of the conclusion of the formal meetup tonight. Feel free to stick around if you like. And a reminder, next month we won't be here. We'll be at Mantle for the WWDC Spectacular. But please let me know if you'd like to be on that panel. I do need people. And I will be bugging people in Slack if I don't hear from you tonight. So it'd be great to hear from a few more people tonight. But thank you and get home safe.